And good morning, everyone. It's so great to be here with all of you on the 20th birthday of JFall. So awesome. So let's get the blood flowing a little bit. Raise your hand if you're a software developer. Cool, almost all of you, my kind of audience. Keep your hand raised, keep your hand raised. Now keep it raised if you call yourself a software engineer. Oh, only a few hands going down, interesting. I'm Sander Mak, I work at Picnic, and I used to be like a lot of you as well. I used to call myself software engineer without thinking too much about it. But I must admit, over the past years, my thinking has changed a bit around that. And that is why I want to take you on this journey to the art of software development this morning. And I hope I can provide you at least a bit of food for thought. And I'm not saying that you cannot call yourself a software engineer. It's a free country, right? So, but in the end, I want to give also sort of a counterpoint and share that there's maybe more art to what we do than we give it credit for. So you might be wondering, what is this all about? Because everyone calls this software engineering, right? So if everyone calls it that way, it must be right. And if you go back, you can even find this seminal conference by NATO called the Software Engineering Conference, very early in our field. So you might think, well, this is a solved problem, right? Case closed. Well, if you look a little bit deeper into this, you will actually see that they named this conference a Software Engineering Conference deliberately to make it provocative, because they knew software development is not quite the same as some of the other engineering disciplines that you associate yourself with if you call yourself a software engineer. But you might also say, whatever, that was 60 years ago. What if maybe next year we would hold a new NATO software engineering conference? Instead of JFall, just here in Ede, we could, in good conscience, call it a software engineering conference, right? Because a lot of things have happened, a lot of things have changed. And of course, yeah. But first of all, be careful what you wish for, right? And for the non-Dutch participants, this is our Prime Minister who's actually angling for the head of NATO role. I don't think Mark is going to solve all of our software engineering challenges. And yes, we've become better. We've become much more disciplined about the way we do our jobs. We have lots more tools than in the 60s. But I still think there's a fundamental difference between straight engineering and the work that we do as software developers. Right, so what is this difference then? What is it about engineering that might be different? And if you look at the term engineering, of course, it goes way back before software engineering. It even goes way back before this NATO conference that I showed. Because we had electrical engineers, civil engineers, and many kinds of engineering disciplines that all built on a vast base of scientific knowledge that are also quite often highly regulated. But if I were to sum up the single biggest difference between these engineering disciplines and between software development, the word for me would be accountability, right? Because let me ask you a question. When was the last time you actually signed off on a piece of code certifying it was bug-free? I guess none of you, right? And I would think very hard before doing that. So there's a pretty big difference in the terms of accountability and also the sort of ethos around these kind of engineering roles. And actually, what triggered this whole thinking for me in the talk that I'm giving here is this article that I found in a Canadian paper, where it says, actually in Canada, there's a regulator that said, you cannot just call yourself a software engineer just because you know HTML and etc. This is a protected title. It really means something. And if you look into this article, it says, professional engineers are held to high professional and ethical standards and work in the public interest, it said. The public places a high degree of trust in the profession, and these layers of accountability and transparency help keep Canadians safe. Wow. If you read that, you want to be an engineer, right? But remember, this was an article about how software developers could not call themselves engineers in Canada. So it seems that there's also from the regulation side a bit of a difference there as well. Now, what if we turn this around? What if engineers would maybe work a bit more like software developers? So let's say someone comes to you and says, let's build a bridge, because let's face it, that's also sort of the level of requirements that we tend to get, right? So of course, then the engineers, thinking as a software developer, might say, sure, I'll give you an MVP in 2 sprints, right? Well, I don't think that will lead to a bridge that I want to walk over, right? we intuitively know that you cannot iterate your way to a bridge, and that you indeed have a kind of different engineering approach there. Whereas in software, we do work in a more incremental, iterative way. So then the person says, well, maybe we should try science, right? So there's lots of science behind building a bridge. But interestingly, of course, there's also a lot of science behind software development. We have computer science. I studied computer science. I think a lot of you did. I love computer science. I think it's indeed a very big part of our field. And there's many, many concepts in there, right? There's these eternal truths around data structures, algorithms, big O, complexity. Take, for example, recursion. Now, we, of course, all know that to understand recursion, you must first understand recursion. But I'm going to assume that you're already there, because otherwise I will take up the whole morning, and that's not fun. And recursion is a super useful computer science concept. It even appears in real life. Let this sink in for a bit. So Hitman hires Hitman, who hires Hitman, who hires Hitman, who hires Hitman, who tells the police. So it's got everything, right? It's got the suspense, the drama, the base case, where the Hitman says, well, for this amount of money, I'm not going to do it. I'm just going to turn us all in. But anyway, there's a link to reality. But let's face it, in our day-to-day work, we don't apply these principles, right, too much. And I'm going to assume that we're not working in academia. Some of you might. Then you're a computer scientist, sure. But in our day-to-day software development work, yes, we do use a lot of output from computer science, compilers, and all of the fancy tools and things around that. But our work, it's not really computer science. There's part of it, but it's not the whole story. And I'm afraid to admit that the most we often interact with computer science, unfortunately, in our day-to-day, is when we go looking for a new job. Yeah, sorry. Anyway, so what is it then? Where does this leave us? I think, in the core, we are problem solvers, right? So we look at a domain, and this can be any domain. Maybe you're working in the financial sector. Maybe you're doing warehouse automation. Maybe you're in e-commerce. But there's always a domain where there are problems to solve. And sort of the traditional thinking is then, OK, we as software developers combine this domain with our computer science and software engineering kind of background, and this leads to great software. Well, sounds nice. But if this were the case, then we wouldn't have projects that would be late. We wouldn't have these high-profile outages, even at Google, Facebook. Even yesterday, OpenAI having a very big outage. So I do feel that this is not a solved problem, and that there's a lot of art and sort of, non-scientific engineering that also goes into the art of software development. And I think art does not get enough credit here. So what I want to do is I want to look a bit more with this lens to the work that we do, rather than thinking it's only straight computer science or it's only straight software engineering. So congratulations, you're an artist, right? And when you think about it, it makes sense. Because when we develop software, there's no boundaries, right? We can start from a blank slate. There's infinite possibilities. There's many ways to do things. So it takes a lot of judgment. It takes a lot of artistry to actually get to a good outcome there. And the cool thing is, I'm not the only one to think so. I love this quote from John Romero from ID Software, who created Doom. He says, "You might not think that programmers are artists, but programming is an extremely creative profession. It's logic-based creativity." And I really love this sort of tension between logic and creativity here. I think it really hits the mark. Now, of course, I also know that we're not always creating new things from scratch, and we're not always feeling like artists, right? So we also sometimes practice the dark art of copy-paste-driven development. Well, I'm guilty as charged. Anyway, but usually I think there's a very, very large part of artistry also to software development. Because when it comes down to it, as a software development, if I were to sum up what we do in a single word, it would be abstraction. So we take something in the real world. For example, with Picnic, we want to make online grocery shopping as fun, easy, and affordable for everyone. To do that, we need to create a lot of software. We need to look at the problems that we see in the real world. We need to automate that. But at the same time, we also need to leave things out, because you cannot automate everything. You cannot do everything. So you need to find the right abstractions. You need to find the right way to model this. And that is really where the art of software development lives. So in this case, we're doing something similar to what artists are doing. They're looking at the world, And they are creating an abstraction, they create a visual, a sculpture, or whatever that is pleasing, that is useful, and that is also what we are doing. But instead, our canvas is the IDE, and our paint is the code that we use to create these abstractions. And of course, there's many aspects to this, right? So it's not just coding, but there's also testing, there's also design of our software, there's also the whole process around this, where all of these aspects do involve also art. So in the short time we have together this morning, I cannot talk about all of them, but I want to highlight coding and design and their relation to the art of software development with you. So let's first have a look at code, or as I call it, the truth, right? Because in the end, you can have the best process, the best design, the best ideas, the best tests, etc. But if your code isn't right, then you're done for. So let's see what we do here. So what is good code? Here we have, of course, the Mona Lisa. It's widely regarded as one of the most beautiful paintings. And why is it, right? Is it the haunting eyes? Is it the elusive smile? Is it the use of color? Or, I think it's a lot of that, indeed. But it turns out that you can also go a layer deeper and analyze this a bit. And you might see this. Who knows what this is, by the way? Yeah? This golden ratio, indeed, right? Very good. So that starts you see some emerging principles here also behind art. And you might ask yourself the question then, what is sort of the golden ratio of code? Maybe it's something like this. Well, I hope not. I admit there's something very aesthetically pleasing about a street fighter sort of indenting your code. But no, hopefully not. And I'm super happy that we get Loom and virtual threads, saving us from callback hell, etc. But when I talk about the principles of good code, it's not about how the code looks. Again, this is actually running C code, super nice, submitted to the International Obfuscated C contest. But it's not about crafting these little snowflakes in your source code when I talk about the art of software development. In fact, quite the opposite. I think there's a lot of beauty in uniformity. So at Picnic, we, for example, use Google Java format to just format all of our code automatically, no discussions anymore around this, and you can focus on what really matters, right? So I would highly recommend you checking out one of these tools as well, because it saves you so much time in terms of reviewing and discussions that don't lead anywhere. But still, what is then the art of writing good code? So let's go back to the Mona Lisa. Why was this painting made? Well, turns out there was this guy called Francesco del Giacondo, who just wanted a pretty picture of his wife. And I mean, this was before Instagram, right? So what do? You call Leonardo da Vinci, and you ask him to make a painting. So this painting is not there because Leo wanted to try out and fiddle with the golden ratio and whatever. There's a clear purpose why this painting was made and how it turned out this beautiful. By the way, in the end, Francesco did not get the painting. Leo sold it to, I think, a French king because he bid more money. Not sure what that tells us about what we should do with the code that we write, but anyway, just saying. So what is then the art of writing good code? Well, in the end, you really need to connect your code to a purpose, right? So if you do not know why you're writing it, it will never be good code. So as I mentioned, we have many different domains. There's many different problems to solve. But if you really want to write good code, this is the first step. And if you do this, and if you make this the center of your attention, then your pull request reviews will take on a quite different vibe than if you focus on the nitty-gritty details and the formatting that I talked about. So this is the first step to writing actual good code. Solve a problem that needs to be solved, that you connect with, that you care about, and solve it well. Then there's also the notion of context and fit. What is good code is quite different if you're doing, for example, game development versus microservices versus warehouse automation software. I mean, there's no one-size-fits-all. This is not an engineering handbook that you can take and then just do whatever it says there. And also, context can even be very company dependent. So nobody loves the guy who comes in new to a team and says, we need to do this completely different rewrite and rewrite everything. That is not how you write good code. Ultimately, we also care about the quality of our code, of course. So code is read much more often than we write it, and we want to make sure that we also leave it in a state where it can actually be maintained and worked on by other people. So that is also a quality that we're looking for in good code. Now, the first two, they're very contextual. But the last one, I think there's more to say about how the art of writing good code emerges in our industry. And usually when people think of quality code, they think of these kind of books, right? So the clean coding and everything around that. And of course, there's definitely truth in there. There's also a lot of acronyms in there. We're apparently very good at that. But I think the art of writing good code is not about just reading those books and applying all of these principles. Because there's even quite a bit of tension between these principles if you dive into it. For example, if you want to keep it simple, sometimes it's better just to maybe copy and duplicate a bit of code rather than trying to go all the way with don't repeat yourself. So there's a lot of trade-offs and there's a lot of art to actually judging when to use these principles and where to use them. So I would urge you to sort of find your style. And by find your style, I don't mean your personal style, but as a software developer, as an artist, your team and your company, you can decide what is important. You can decide which of these principles apply when and how. And that hopefully means that your pull request reviews won't look like this anymore, looking at sort of nitty-gritty details around white space and usage of APIs. Because once you've had these discussions and once you find your style together, then you can engineer the way, right? So a lot of these decisions you have tools for nowadays. Spotbug, SonarQube, ArchUnit. We use Error-Prone heavily at Picnic to actually also automatically rewrite these kind of things for you, and Open Rewrite is another tool there. So there's lots of opportunities to actually automate these things in a way so that you can focus on what's really important, indeed, what is the problem that you're solving and are you solving it well. So that is one way in which you can do this. So now let's switch gears a little bit from code to design. And by design, I don't mean UX and UI, I mean actual architecture and design. And the question I get a lot is, do we even need this stuff, right? Because we're agile now, and we're doing iterative software development, so this sounds like big design up front. And yes, I know software architecture has gotten quite a bad reputation in the past 10, 20 years, because, well, there's maybe a bit more of a negative connotation with art, like the diagrams that we often see, in this case, in recognizable box and arrow style. But at the same time, this question is not new. So there's this article from Martin Fowler already in 2004 where he asks, is software design, is it dead? Well, spoiler alert, in the article, the answer is no, and that's also my answer, right? Because in the end, we still want to make sure that we build the right thing and that we know that we're going to build the right thing before we actually start coding and coding ourselves into a corner. Because you can make lots of costly mistakes if you skip this step. And while doing software design, you can also uncover lots of risks, assumptions, etc., that you would otherwise miss. And most importantly, again, this has to do with people who come after you, of course, but by documenting, by actually thinking about and documenting your design, you're also enabling your team, your company, to actually survive and to adapt in the future. So, as a wise man once said, weeks of coding can save you hours of designing. So I think with agile software development, maybe we've gone a bit too far. The pendulum has maybe swung too far in the direction of not doing design. So why has it happened? I don't know. If you want to dive a bit deeper into this, I can highly recommend this talk from Simon Brown called The Lost Art of Software Design. Well, you can see how I like this title. But it turns out that as software developers, we find software design a pretty daunting part of software development. I mean, we know code, but doing design, doing architecture, this feels much harder. And it is actually a much more creative part of the process as well. So why is it hard? Lots of people find it hard because there's quite a different feedback loop, right? So there's no compiler to yell at you if you make a mistake. In the end, this is something that is much more outside of IDEs, outside of tools. And software design, in the end, comes down to making trade-offs, making hard trade-offs. And again, there's no engineering handbook that will tell you how to make these trade-offs and where to make these trade-offs, because it depends a lot on the problem that you're solving, the technology that you're using, the context that you're in. And this makes it a very creative and sort of daunting enterprise. And you really need to understand the true problem that you're going to solve if you want to make a good design. And ultimately, design is also communication, right? And communication involves people. People are hard, ergo, design is hard. So what can we do? Okay. I can leave you with one simple tip. So what we want to strive for is we want to simplify. And what I mean by that, we probably all know this quote by Pascal, where he says, if I had more time, I would have written a shorter letter. Well, if only I had more time, I would have created a simpler architecture, right? Well, no software developer ever said that, I guess. We love complexity somehow, and then we're drawn to complexity in a certain way. So why is that? Well, I came across this very interesting study in Nature, where they explained, and this is not about software, by the way, this is a general problem-solving study, where they actually asked people to fix sort of this structural problem. And they said, okay, make it stable. And what did people do? They started adding 3 pieces of Lego to make it stable. Whereas if you would just remove one single piece, you would be done, right? So apparently our brain is wired to favor adding stuff and to building new stuff and to building on top of things rather than taking things away. And I think software design, if you approach it as maybe a sculptor, would be much more interesting and much more effective. So think about in the next time that you need to build a new feature, what can you take away from the existing system? Where can you slot it in rather than just bolting it on and adding more and more and more complexity? And that's super hard, but that is also part of the art of software development. I never said it was going to be easy, right? And then the remaining question is, okay, that's great. So apparently we have code, we have design, and there's a lot of things that we need to do there that take a lot of judgment that we cannot probably take for granted just from software engineering and computer science principles. So how do we learn this stuff? Is it just experience, or how do we do that? So who here knows these books? Right, yeah, it's The Art of Software Development by Don Knuth. But even if you read The Art of Software Development cover to cover after graduating from your computer science degree, you will not be a great software developer. You will be very smart in terms of algorithms, but it's not the same as being able to build software end-to-end. So maybe this is the wrong question, how to get the right knowledge. Maybe we should talk about skills more. And usually I do this talk to foreign audiences, but we're all Dutch, so we all know this is not going to work, right? Riding your bicycle one-on-one. This is an actual book. I'm very curious what's in there. Like, get on your bike, try pedaling and not falling over. I don't know. But we all feel that this is something that we also cannot learn from books and from theory. So what is it then that we're missing? Because obviously knowledge and skills, they're necessary, but they're not sufficient. So I came across this term called metis in a book, and it actually encapsulates exactly what I'm looking for here. It's just a combination of wisdom, skill, and craft. And I came across this in a book called Seeing Like a State. Again, has nothing to do with software, but it defines metis as well, and it says, this metis, it resists simplification into deductive principles which can successfully be transmitted through book learning. So book learning is not enough, because the environments in which it is exercised are so complex and non-repeatable that formal procedures are impossible to apply. And this is exactly where I think the whole thinking about software engineering being only a science or only sort of an engineering discipline, where it breaks down, right? We are in such complex environments, and software is so malleable and so flexible that we need more, need more than that. So still, how do we learn this? I feel that guilds and apprenticeships are very underrated in our industry, right? So learning by doing, but doing so in a guided manner. Having the master and the apprentice relationship, like in the old days with the artists, with the big painters. I think there's a lot of value in there. So at Picnic, we try to do this. We, for example, introduced a Tech Academy program where we target people who are graduating. We hire them, we put them in a team directly, but we give them 50% of their time to actually learn and grow, and we assign a dedicated senior mentor to them who helps them do that. And they will get access to lots of materials, lots of books, lots of courses, etc. But in the end, it's this connection between the mentor and the mentee that is really transmitting this art of software software development, this thing that cannot be captured in books, but that we all know is very important to get to good software. So that's something that I want to leave you with, because I do think it's super important to either find a mentor if you're very early in your career, or to be a mentor for other people if you are already more experienced, to actually transmit this knowledge that is not there in books, this art of software development that we all know that is so important, but it's something that we cannot transmit otherwise. And you can do this either in the context of your company, but it could also work in the context of a community, right? We have a fantastic Java community here in the Netherlands, so why not make use of that and help each other grow in that way? So let me wrap up. In the end, as artists, we also want to leave a legacy, right? And that requires us to work on things that really matter. So I'm really lucky to be part of a company where I feel that I'm really contributing to the happiness of the lives of millions of people. But sometimes it takes a little bit of a wake-up call, right? So I want to give you this wake-up call today. So are you working on something that really matters to you? Are you working on something that really changes the world in a way that you want to see it changed? And if not, then you might not be at your peak in terms of performance of doing the art of software development. So think about that. And then second, like I mentioned, I feel it's super important for our industry to go back to the roots and to start mentoring other people and to transmitting this knowledge here at conferences, but also in other ways, also one-on-one, to be able to spread and get better at the art of software development. So if you want to know how we feel about the art of software development, how we also engineer some of the parts away, like I talked about, then I want to invite you to either go to our engineering blog or come by down at our cute electric vehicle that is parked in the hall downstairs. We'd love to talk to you about that. But for now, I want to say, go forth and write some beautiful code.